Imagine you walk to an ATM, you insert your card, enter the correct PIN, and the ATM says transaction declined. But wait, how is that even possible? If the PIN was correct, shouldn't the ATM just give you money? Not necessarily. What if your account only has 500? Or what if you are trying to withdraw 10,000? What if the ATM needs to check more than one thing before giving you money? That's exactly why today's lesson is important. Because this same idea exists in banking apps, login systems, e-commerce websites, even Netflix and Telegram bots. And once you understand this, you start seeing it everywhere. Today, we're going to build a simple ATM withdrawal system. By the end of this video, you understand one of the most important ideas in programming, nested if statements. But before I explain anything, let me show you the final results we're building, because programmers learn faster when they know where they are going. So let's run this code first. I'll enter 1, 2, 3, 4. And look at the results. Withdrawal successful. Interesting. But wait, how did Python know to check the balance only after the PIN was correct? Why didn't he just check everything at once? That's the mystery we're solving today. Before we continue, remember our mental model. Say it with me. Every program is the same. Input, rules, output. Now let's find them. What is the input? Right here, these are the inputs: PIN, balance, and amount. These are the pieces of information entering our program. Now, the rules: if PIN, if balance. These are decisions. And finally, the output: print withdrawal successful, print insufficient funds, print incorrect PIN. Nothing magical is happening. It's just inputs, rules, and output. The only thing changing today is that our rules are becoming smarter. Now here's the problem with one if statement. I'm going to remove everything here. Now think about this. If somebody enters the correct PIN, should we immediately give them money? No, because we still don't know whether they have enough money. Is only the first checkout or checkpoint rather. The ATM still needs another decision, and that's where nested if statement comes in. Now, what is a nested if statement? I'm going to show you something now. Watch this. Notice something. We have an if statement. We have another if statement inside this if statement. Now, this is what you call a nested if statement. Think of it like an airport security. The first checkpoint, they will check, do you have a ticket? If you have a ticket, you go to the second checkpoint. Do you have a passport? If you have a passport, you can continue. The second checkpoint only matters if you pass the first checkpoint. And that's exactly how nested if statements work. Now, let's test your understanding. You're going to predict the output before this. What do you think will happen? Will Python print withdrawal successful or insufficient funds? Decide before I run it. So, are you ready? Okay, let's run it. Withdrawal successful. Now, let me edit something. Now, what do you think will print? Withdrawal successful or insufficient funds? Let's run it and see. Insufficient funds. So let's investigate why the first was withdrawal successful and this one was insufficient funds. If you look at our balance here, balance is 500 and we're about to withdraw 2,000. Obviously, we cannot withdraw 2,000 from 500. Who's going to pay the remaining 1,005? So because of that, we get the insufficient funds. So let's walk through the rules. The rule said if our PIN is 1234, we check for the second if statement. And remember, our PIN was 1234. So we passed the first gate. Now the second gate came. If our balance is greater than or equals to the amount withdrawing, we can withdraw. It will print withdrawal successful. But it checked here, our balance was lesser than the amount we needed to withdraw. That's why it skipped this if and went to the other one, which is the else statement, which said print insufficient funds. So since this was not true, it printed this. That's why the withdrawal failed. So let's use our framework again. Input, rules, and output. The input was not enough to satisfy the rules, so the output changed sufficient funds. Now let's break this program. Let's see if we can fix it back again. And we'll debug it step by step. Debugging is very important in programming. So let's run it first to see where the issue is from. Syntax. Line 6. What happened to line 6? Remember what I always said, we have to close the colon. We close it and save it. Let's see what passes this time. We expected to have a column here. You can see the error actually tells us what we should do. Expected colon at the end of this. So we'll do that as well and save it. Let's run it again. Expected an indented block after if statement on line 6. Okay, so that means this should be indented. This is what you call indentation. Use your tab button. This is indentation. Let's save it and see if Python agrees. Another indentation. So it wants us to indent this as well. Let's see what happens again. It actually worked, but I think we're going to receive an error when we reach to this else statement. I'm going to see what I'm talking about. It crashed. It did not get to this else statement because it was not indented. So let's do that now. Indent, save it. And why it also did not print it was because we did not spell print well. Let's spell that well. Let's save it. Let's run it again. Let's put our pin. And boom, insufficient funds. That's how you debug. Debugging is not important. You should not run away from it. You will learn a lot if you're debugging. And Python helps us a lot by telling us what the error is. So you can see our code is now working really well. Let's try one more challenge. Let's say let's make it simpler. We're not going to input here. We're just going to say pin as a variable. Let's say pin is our pin. We changed our pin. Our pin now is 9999. Let's say our balance is 5,000, amount 2,000. But what we're going to do now is we're going to change this to incorrect pin. Save this as well. So think about it. What do you think will show, or what do you think will be the output? So let's run it. We'll have to indent this well. If not, we're not going to receive what we are looking for. So let's save it now. We'll run it again. Incorrect pin. So here's the important question. The Python even check the balance. Python not even check the balance. Why? Because it failed the first checkpoint. Pin is equals to 123. Our pin was 9999. So it did not even check the balance. It stopped here. This is the important thing you learn today. The inner decision depends on the outer decision. If the outer decision fails, the inner decision never runs. That's the power of nested if statements. And this idea is everywhere. Banking apps, login systems, Netflix, inventory system. Imagine Netflix now. Netflix's first question now is, are you logged in? If yes, the second question is, do you have an active subscription? If yes, then they show you the premium content. That is the decision inside another decision. Nested if statements. Real software use this pattern every single day. Now it's your turn. I think you should build a movie theater entry system. The rules are, you first check if the cost, you check if they are old enough. If both checks pass, allow entry. Before you start coding, identify the input, rules, and out, then build the solution. So today we learned how software makes decisions inside other decisions. And that's exactly what nested if statements are. But there's still a problem. Right now, our ATM only gives the user one chance to enter their PIN. What if they get it wrong? Should the program immediately stop, or should it keep asking until they get it right? That's the problem we'll solve in the next lesson. And to solve it, we're going to learn one of the most powerful tools in programming, loops. So I'll see you in the next video.